Hello, my dear students. Today we'll complete our first lesson on the law and electric circuit, electric current. Okay. Last session I talked about the electric resistance. What does it mean, electric resistance? Electric resistance is the opposition that faces the electric current. How can we calculate the electric resistance? Electric resistance are equal rho L over A. What does it mean, rho? Rho, it is the electric resistivity of the material. It depends on the type of material and the temperature of the conductor. Okay, right. A is the cross-section area of the wire. Right. And another physical quantity called electric conductivity. Electric conductivity means it is the reciprocal of the electric resistivity, and it is also constant. Okay, it doesn't depends on the length of the wire or the cross-section area of the wire. Okay, the measuring unit of the electric resistivity, it was ohm times meter. The measuring unit of electric conductivity equal ohm minus 1, meter minus 1. Okay, right. The scheme of this relation equal A equal 1045 equal 1. ماشي بقى؟ طيب. We have an example here. A wire of length 20 meter has a cross-section area of 0.2 millimeter square. If the applied potential difference between its ends equal 10 volt and the electric current intensity passing through it equal half ampere. Half ampere. Right. Calculate the electric resistance. Electric resistivity equal R A over L. Right. We have the cross-section area and we have the length. What about R, the electric resistance? Electric resistance equal V from Ohm's law equal V over I. V over ايه يا شباب؟ V over I يبقى 10 over half equal 20. Okay, طيب. This is the electric resistance. And use your calculator A, you will get the electric resistivity. The electric conductivity 1 divided the electric resistivity. Okay, 1 over the answer يعني. كده. طيب. We have a wire and it is wounded or reshaped into the form of circular coil. In the form of what, شباب? In the form of circular coil. If you have wire in the form of the circular coil, okay, the length of the wire is constant. The length of the wire is constant, equal 2 by R times N. 2 by R is the circumference of the circuit. 2 by R times N, where N is the number of turns. N يا شباب is the number of turns. Okay, right. We have an example. A wire of cross-section area equal 10 power negative 6 millimeter, meter square, and the material resistivity equal this what شباب؟ this the rho. هي ايه؟ electric resistivity اسمها ايه يا شباب؟ rho E. is wounded in the form of circular coil of radius equal 7 over 22 meter. The number of turns is N. Okay, and this is the radius. The terminal of the wire are connected to an electric source, so the potential difference between its terminal becomes 50 volt. Comes out شباب 50 volt. Calculate the electric current intensity passing through the wire. Okay. To calculate the electric current intensity, we have low here I. يا شباب I equal I equal V over what? V over R. Okay. Mister, we want to calculate R. R equal what? R equal rho L over A. Rho L over A over A. Right. Here we have rho, and we have the cross section area, okay, and we have R and the number of terms. Right. How can we get R or calculate R? R will be calculated from the relation rho L over L. Right. We need L. L, we will use this law equal what? 2 by R times R, 2 by R times L. يبقى يا شباب 2 باي this L بقى 2 باي times R اللي هي ايه؟ 7 over 22 7 over 22 times n number of terms equal what? Equal 100. Equal يا شباب 100. Okay? The measure unit of radius is meter. So this is the value of y and this reciprocal of value of y. يبقى 2 times 100 equal what شباب؟ Equal 200. So the length of the wire equal ايه؟ Equal 200. The length equal 200. L equal ايه شباب؟ Equal 200 meter. So now we can calculate R and use it in E to get the current intensity. يبقى 50 divided the value of R equal 20 ohm, يبقى 50 over 20 ohm equal 2.5 ampere. 2.5 يا شباب 2.5 ampere. To determine the resistance of the wire using the mass and volume and density of material, density of material symbolized by rho, okay? Not like what? Not like rho E. Take care about these A symbols. This is the density of material. This is the electric resistivity of the material. Okay? Both of them depends on the type of material and its temperature. R equal rho L over L A. Right. What is the relation of density and the mass and the volume? Density of the material equal mass over the volume, and the volume equal A times L. A is the cross section area of the wire, and L is the length of the wire. Okay, شباب؟ طيب. What will happen if we multiply L times A and A times A? يبقى we will write here A over A. A over A شباب over A. What will happen? Nothing happen. L times A equal what? Equal volume. We will write volume here. طيب A times A equal A power 2. اوكي يا شباب؟ طيب يبقى R اللي هي electric resistance equal rho E volume over A power 2. طيب volume from this relation equal mass over A over the density. Mass over A over the density. Okay? طيب we have an example here on this point. This is the last one. A copper wire of length 50 centimeter and the material density equal ماشي. طيب ده كده يا شباب اللي هي الرو. So it has resistance equal and we have R. Okay. And the mass of the wire, calculate the mass of the wire. He needs the mass of the wire. You will use this relation. طيب R equal rho E L over A. يبقى the electric resistivity times the length over the cross section area. Okay. طيب but now we don't have the cross section area. But this problem has a mistake? No. We multiply L and L to make this problem of a one unknown. Okay. L over L. طيب يبقى L باور 2 هنا A times L. هنا يا شباب في L وهنا ايه L. A times L equal A equal the volume from this relation. يبقى rho L باور 2 over الفوليوم. rho E L باور 2 rho over ال M. Again, يبقى the volume from this relation equal what? Equal mass over A the density. Mass over A the density. يبقى volume equal mass اهي يا شباب over A density. اوكي؟ طيب We have the density of the material, we have the electric resistivity, and we have the resistance. So mass can be calculated from this from this relation. Okay, شباب؟ طيب. This notes for comparing between two resistors of the two conductors. Huh? If the two conductors of the same material, hmm, يبقى rho E equal rho E and rho 1 equal rho 2. يا شباب؟ So hmm, يبقى ايه؟ remaining part هيبقى ايه يا شباب؟ remaining part يبقى L1 power 2 M2 over L2 power 2 M1. If the two material of the same, if the two material of the same of the same, the two wires of the same material. So the electric resistivity will be the same and the material density will be the same. So it must be cancelled to be for each other like this. Okay. Right. Let's start the second lesson. Second lesson talks about connection of resistors. Connection of resistors. Last session we have talked about electric resistance. We have two types of the electric resistance: fixed resistance or variable resistance. Okay. Right. We have two ways of connection of the lamps of the electric resistance. We have what شباب? Two ways. First one, series connection and parallel connection. First and series connection and parallel connection. Let's start with a series connection. Look at the opposite circuit. We have a battery, switch, and two lamps, two electric lamps or two fixed resistance. Okay, two fixed resistance. Right. What is the importance of this connection in series? Obtaining large resistance from a group of smaller resistance. Okay, obtaining large resistance from a group of resistance, equivalent resistance equals the sum of the two resistance, the sum of the two resistance, and the total resistance larger than the largest resistance because it is equal the summation of this resistance. For example, if R1 equal 2 ohm, R2 equal 3 ohm, and R3 equal 5 ohm, the summation of this resistance will be what, شباب? Will be more than 5 ohm. ليه? Because the equivalent resistance equals the sum of this resistance. Equal what, شباب? The summation of this resistance. What about the reading of the ammeter and the voltmeter of H1? What about the reading of ammeter and voltmeter of H1? The reading of ammeter, it will be the same. Why? Because it is in the same way or the same route. It connected in series connection. So the current in the first resistance equals the current in the second resistance equals the current in the third resistance. Okay. What about the potential difference? Is the reading of voltmeter in this point equal V1 or equal V2 or equal V3? Huh? The reading of the voltmeter equals the summation of this voltmeter equal V1 plus V2 plus V3. Again, when we connect the resistance in series connection, the reading of ammeter equals the same. Okay, doesn't change in the series resistor when it's connected in series, but the reading of voltmeter different from each one according to their values. Okay. Right. When I remains constant, the largest potential difference in the largest resistance. It has direct relation. V1 over V2 equal R1 over R2 when I is constant, when I is a constant. From Ohm's law, we can get the equivalent resistance, which is symbolized by R dash equal V equal I times R. This is V total. V1 equal I1 R1, V2 equal I2 or I only R2, V3 equal I R3. Right. When calculate the total voltage equal V1 plus V2 plus V3, I is the same, I is what شباب is the same. So I R dash equal I bracket R1 plus R2 plus R3. I is the same I, so it must be cancelled. So R dash equals the equivalent of the summation of this A total resistance. If the value of R is constant or the same, you R dash equal N times R. So when we connect the resistor or the resistance in series connection, the equivalent resistance equals the summation. When they have the same value, if we have three resistance like the last example, if we have three resistance and each one equal 3 ohm, so the total resistance of them equal what? Equal R times 3, يبقى 3 times 3 equal 9 ohm. If it has the same the same value. Choose the correct answer. When the variable resistance increases, the intensity that passing through the circuit increases or decreases. When again, when in the opposite circuit, when the variable resistance increases, the intensity of passing current in the circuit will be. When the variable resistance increases, when the resistance increases, the R dash, the total resistance of the circuit increases, so the current intensity will decrease. So I will decrease. Why? Because the potential difference is constant. The volt of this battery is constant. The volt of this battery is H is constant. Equal V equal I current intensity times R dash times H times R dash. Okay? When the value of the resistance increases, the current intensity will decrease. Okay? Let's to see the first choice decreases at point C and remains at point A, but or becomes at point B greater than point C, or remains unchanged at all points over the circuit, or decreases to the same value or all the points on the circuit. This is the total current. Swatch back the total current, and the current in this point at point A is the same at point B, the same at point C, until it reaches or returns to the A battery again, and so on. They are connected in series connection. They are connected in series connection. Okay? So it will decreases to the same value of global A. So the answer will be later. Okay? We have an example here. We have a three resistor, each one of them 85, 70, 25 ohm are connected in series connection with a battery of 45 volt. Has negligible internal resistance. Calculate the equivalent resistance of this resistor. To calculate the equivalent resistance when they are connected in series connection, it must equal what? Must equal the summation of the two resistors. Okay, the summation of the two resistors are equivalent equal R1 plus R2 plus R3. Okay, equal what شباب بقى؟ equal 85 plus 70 plus 28 plus 25 equal the summation of them equal what? Equal 108. Equal ايش شباب؟ 180 ohm. 180 ohm. The measurement of the resistance is 180 ohm. Okay, طيب. The electric current intensity passing in the stereo resistor. When they are connected in series, they have the same value of the electric current. They have the the same value of the electric current. So to calculate the electric current intensity of H1 all over the circuit, it will be the same if I equal, we'll use a Ohm's law circuit, V over LR or V over R equivalent طبعا. طيب the total voltage of the battery equal 45 equal يا شباب 45 divided 180 45 divided 180 يا شباب 45 divided 45 divided 180. Wow. 45 divided 180. يا شباب طب equal quarter ampere equal يا شباب quarter ampere يبقى 0.25 ampere. اوكي طيب the potential difference of each resistor, the potential difference of each resistor equal I times R. I times A R. It has the same value? No, they are different. Okay, so V1 equal quarter times 85, V2 equal quarter times 70, V3 equal quarter times 25 to get the value. If you want to calculate the total voltage of the circuit, equal V1 plus V2 plus V3, it must equal 45 volt when the internal resistance of the circuit equal 0, or of the battery equal 0. If you want to make a check up for the value of the battery, calculate this value of the voltage. It must equal what, شباب? It must equal 45 volt. It must equal 45 volt. The total voltage equal 45 volt. Okay? It's a summation of them. Okay? Today we have finished the first part of lesson 2. Next session, inshallah, we will complete lesson 2 and solve some examples of this resistance. Okay, thank you.